Hello, 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 hello. Hello, dear students. Welcome back to my YouTube channel. I hope I'm audible and visible to all of you. I hope that I'm audible and visible to all of you. Am I? Hello, beta. Okay. I guess yesterday, due to some sort of internet issue, right? We did not complete yesterday's class. So what we will do today, now we will just complete the rest things that we had not discussed yesterday. Okay, firstly, I will just give a quick recap of yesterday's session. So we started EMI, electromagnetic induction. The first topic that we just did now, and that was okay. Now my screen is visible. So basically, we completed one topic, that is a magnetic flux. And magnetic flux means the number of magnetic lines of forces passing through your area. Okay. And if the angle between the area vector and your magnetic field lines, forces lines, are parallel to each other, so we can call there will be a maximum flux. And if the angle between the area vector and the magnetic force lines are 90 degrees, so the flux is 0. So then we conclude with the generalizing formula, that is phi equals to BA cos theta. It is a scalar quantity. So we conclude this topic, right? After that, we done two things, that is, if we are having an open area or open surface. Second one, if we are having a closed one. If we are having an open one, so we need to draw a area vector which would be a perpendicular to your surface, and the theta would be the smaller angle between your B and between your area vector. But if we are dealing with a closed surface, so we need to take area vector which is perpendicular to that surface and also outwards. I guess these things we concluded in the yesterday's class, and we did a couple of numericals. Okay. Now today we will start our class with this particular question. Done. So what we are having now? So we are having a solenoid which is a 4 centimeter in diameter, and 20 centimeter in length. You can just see it, no? We are having a solenoid which is 4 centimeter, whose radius diameter is 4 centimeter, and length is 20 centimeter, and it has 250 turns and carries 15 ampere current. Calculate the flux through the surface of a disc whose radius is 10 centimeter. So that simply indicates we are having a solenoid, and it is like this. Okay, and current I is flowing through this one, and we are having a magnetic field, and magnetic field will be in this way. We know it now. Okay, and this would be a north phase, this would be a south phase. This radius of this solenoid, and it is given as 2 centimeter. I can write it as a 2 into 10 to the power minus 2 meter. Length of this solenoid, and it is given to us as a length is as 20 centimeter. So 20 centimeter, I can write it as a 20 into 10 to the power minus 2 meter. Done. Okay. Now what is next part? Next part is we are having a disc. A radius is 10 centimeter. That means we are having something like this. No? This is my disc, and it is radius is how much? 10 centimeter. So this radius is 10 centimeter. 10 centimeter simply indicates 10 into 10 to the power minus 2 meter. So we now need to draw a perpendicular, that is area vector on it now. So area vector would be like this. Area vector, no? You can take also this area vector, no issue, but you need to take the smaller one. Okay, angle between the B and A. That is this one. So now, what is the angle between your magnetic field and A? I guess theta came out to be 0°. Yes, sir. So now use this equation to get my answer. What is phi? What is phi? Sir, phi means it is B A cos theta only. What is B? I guess B is given to us. No B, but we know inside the solenoid, B is nu naught Ni. Nu naught is permeability. N means number of lines per unit area, per unit length, and I is current. Area. What is the area of this particular surface? It is pi r square. Yes, sir. And we are having cos 0°. Nu naught. I guess nu naught is nothing. It is 4 pi into 10 to the power minus 7. Done. What is n? N means we are having 250 turns. Okay. N simply indicates n by L. What is n? It is 250 turns. What is length? Length is 10 centimeter. So instead of n, I will write 250 divided by 10 into 10 to the power minus 2. I. What is current? Sir, current I guess is 15 ampere. Done. What is pi? Pi is pi only. Which R you need to take now? Okay, look, we are having two R's. We are having a radius of this disc, right? And basically, but the area now, which is applicable, that is only this much. Why? Because flux is only crossing this much area now. Flux is only crossing this area. Look now, you can see the area is this one. No? This one is this one. So we need to take the radius of this solenoid, not this one. So what is here? What is here? R. What is R here? Sorry, it is 2. This one, no? So I can write 2 into 10 to the power minus 2 meter. Let us do a calculation now. Do a calculation now. Look, pi into pi, we are having pi square. So we can write pi square approximately equals to 10. Okay. So look now, beta. 1 second. What happens to it? One second. Okay. Now look. So I can write, instead of these 2 pi, I can write 10. Then we are having 4 into, we are having 250. We can 250. Done. We are having 15 into 2 now. 2 and cancel, 15 cancel this much. Then we are having 10 to the power minus 7 minus 2 whole divided by 10 to the power minus 1. Okay. So look, 1020. So I can write here, sir, plus 20. It gets up, so it will be plus 1 here. So we are now left with 45 into 4, that is 100. 15 into 2, that is 30. 10 to the power 7 minus 7 minus 2, 9. Or cancel out, minus 7 plus 1 minus 6. 2030 plus 3. It is 3 into 10 to the power minus 3. It is 5. Done? Is this correct? Huh? Any issue with this one? One second. Basically, length is okay. This length now here it is not 10, it is 20 now. It is 20. 20 this one now. 20. So why we are just doing this one? It is 20. So I can write multiplied by 2 divided by 2 divided by 2. I guess my answer came out to be wrong, no? Somehow wrong. Let us do from this particular phase, no? I guess my answer is not correct due to this particular thing. 1 second. 1 second. So basically 4 pi into pi, that is, I can simply write 4 pi square, no worries. 10 to power minus 7 plus 1 minus 2, done, cancel out. So we are now left with 25 into 15 into 2 divided by, it is 220, 10 to power minus 2, 1 0 cancel out. So here we are having 1 only. So I can write 2 to cancel out. So it is 4 into 10. 1 second. It becomes upside, so cut out, it is plus 1. So we are having 10 to power 1 2, it is 7, it is minus 7, then into 25 into 15. Okay, now so I have 25 into 15, 5 5 25, 10 11 12. So we are having 25, it is 5 7 3, it is 375, 375. So 4 into 375, 10 to power minus 6. Am I lagging? Am I lagging? Huh? Am I lagging? 1 second. Yeah, still now the issue is there now. 1 second. Okay, now you can see now pi r square, here is square. I am just doing some calculation mistake just because I was not present. Now I just came in a rush, so I need to do the calculation once again now. I was not present, right? So 1 second, 1 second calculation. Just having this calculation mistakes now. Can do it. Okay, no worries. So first I need to check this whole thing. Now look now. BA new node done. N is done. I is done. Pi is done. It is r square. R square is done. Okay. Is r this much? Yes. Now I can write 4 pi into 250 into 1 5 into 2 4 into 10 to power minus 7, 10 to power minus 4. Okay. Then we are having 20. It will go up. It is 20 power plus 2. 0 0 cancel out. 2 1s 2 2s are 4. So it is 40. 25 into 15 is 375. 25 into 15 375. 10 to power minus 7 minus 4 plus 2. 1 cancel out plus 1. So now we are having, this is 375 multiplied by 4. It is 1500 into 10 to power 7 4. 2 plus 3 minus 1. It is minus 7 plus 3 minus 4, right? Minus 8 plus 2. 15 10 to power minus 6. Okay, this is my answer now. You can cross check this one. Huh? Just cross check this one. Cross check this one. Okay, I guess it is correct now. Just cross check this one. Okay, let us do one more numerical. Okay, let's start one different topic, right? Different topic. The topic is, it is Faraday's law of EMI. So what is the statement for this one? What is statement for this one? So you can write there, whenever there is change in flux and induced EMF gets generated inside loop, this thing is known as EMI. So what is the meaning of it? So let's suppose we are having a loop. This is my loop. Look, we know that if we want to flow the current to this loop, we need a potential difference, we need a voltage, we need a EMF, right? So what Faraday discovered now, so he just placed a magnet here like this, and we know that through this magnetic lines emerges, right? So he just pushes it in this way. So what happens to this one? You can see now these lines, that is flux changes. How, sir? Initially it was here. Initially, no. So you can see no flux. Then initially, then finally it is here. It is changing now. Look, it is changing. So you can see the flux. The number of lines getting through the surface is increasing. That means flux is changing. So what he observed, he observed that whenever this flux is changed across this loop, so we observed here one thing, that in this loop we observed current. In this loop we observed current by the help of galvanometer. So we conclude that whenever magnetic flux changes through any loop, there will be an induced EMF. Induced means due to the motion of relative motion of the magnet, there is a EMF. It is induced. It is not originally one. It is induced one. Okay. Done. So you will find later on due to the Lenz's law, sir, it will get opposed. So we are having here this current, direction of current, right? Why? Because it should oppose it now. As of now, at this particular stage, we are having focus now that how this flux gets changed. Flux gets changed due to the relative motion of this magnet. So we got the induced EMF. It was given by the Faraday's law of EMI. Okay, now look, he just wrote the mathematical modulation of that is mod of E equals to d phi by dt. That means the rate of change of flux. How fast you are changing your flux. According to that, we will get our induced EMF. That means voltage, something like that, no? A potential difference. So what is this much? This is induced. So we can write it is an induced EMF. What is this particular thing? Rate of change of flux. Rate of change of flux. Nothing very hard, no? Induced EMF depends on rate of change of flux. With more flux change, more EMF. Low flux change, low EMF. Now, what we are having now, if we are talking about induced EMF, so we are having two types. We are having two types. One type is instantaneous. One is average. One is instantaneous and one is average. Instantaneous means at a particular instant of time. Average means for a long period of time. Instantaneous means at a particular instant of time, right? Let us suppose we are just very used to the instantaneous speed and the average speed. No? Instantaneous means, let us suppose you want to find the speed of the car at 2 seconds. That means when my watch is giving 2 seconds, exactly what is the speed of your car, that is instantaneous. Second part, find the speed of your car in first 2 seconds. That means after the end of 2 seconds, 0 to 2 seconds, what is the average in this particular instance? That is the average one. There's a major difference between these two. No? So we can write, sir, E equals to d phi by dt, or E equals to minus d phi by dt. Minus you will find in Lenz's law. Don't worry, just remember this one, Lenz's law. After this topic, right? Average simply indicates it is delta phi by delta t. Delta phi means change. It is phi 2 minus phi 1 divided by t2 minus t1. Very easy, no? So now one more thing that we will conclude in this topic, that is induced current. That is induced current. If my wire is there, if potential difference is there, we will get a current. And we know that V equals to IR. But here I will write, instead of V, I will write E. I and R. So therefore, I will write I equals to E by R. This is the equation of my induced current. Okay, if this thing is clear to you now, let us do a numerical. Simple numerical that will give you an idea how to do numericals. We are having a coil and the resistance of my coil is given as 400 ohm. Okay, and this coil is placed in a magnetic field. The coil is placed in the magnetic field. If let us suppose if my flux is time dependent, my flux is not constant, it is changing with the time. Clear? So what we need to find current at 2 seconds. Look now, it is at 2 seconds, that simply indicates instantaneous current. Sir, how we can do it? Sir, I guess my current is equals to EMF induced by R. R we know now, but E we don't know. So how to find E now? Sir, we have an equation now. E equals to d phi by dt. Yes, sir. I can write d by dt instead of phi. I will write 50 t square plus 4. Can I write 50? The differentiation of t square is 2t, right? And the 4 is 0. So is it 100 t? Yes, sir. Now I don't know the exact value of it. It is time depending. So, but we are giving it 2 seconds. So can I place E t equals to 2? Is it 100 into 2? Is it 200? So can I write here, is it 200 by 400? My answer came out to be 1 by 2 ampere. Easy or super easy? Is this easy or super easy? Easy, no? Very easy things and normal things. Okay. That's one more numerical. Somehow bigger from this one, no? So now my B is given. It is 2 10 to power minus 2 Tesla. B is given to me. And my theta, that means if this is my surface of my area, okay, B is going in this way, 90 degree with my surface, like this. Done. And my area is given as 100 centimeter square. And turns given as 50 turns, right? Done. And E average is also given as 0.1. Okay. Done. So find the value of time in which it will become 0. Done. Sir, how to find T now? We have equation now. How, sir? E equals to delta phi by delta T. I can write phi 2 minus phi 1 divided by T2 minus T. I can write like this? Yes, sir. So this is a case of solenoid or a coil. So E, I guess E is given as 0.1. Yes, sir. So phi 2 is 0. So I can write 0 minus phi 1. What is phi 1? I guess it is NBA cos theta. Yes, sir. It is T only. Yes, sir. So now, can I write one more thing now? What, sir? 1 second, beta. Can I write now? 0.1, or I can write one thing now. Look, I can write T is equals to NBA cos theta divided by 0.1. What is N? I guess N is 50. Yes, sir. What is B? 2 10 to power minus 2. What is A? 100 centimeter square. That means minus 4. We're having CAS 0 degree divided by 0.1. Cancel out. Here is 10. Look, now 1 0, 3 zeros, 4 0. Plus 4. This is cancel out. So we are having 5 to the 10. So we are having 10 into 10 to power minus 2. Okay. It's 10 to power minus 1, 0.1 second. Easy or super easy? Easy? Look better. I guess we know one thing now. We know one thing. The thing is, look now. We know one thing now. Look now. Basically, what is E average? Sir, E average is delta phi by delta t. Done. What is I? Is it E by R? What is E? Is it delta phi by R delta t? Clear? One more thing, that I equals to delta Q by delta t, na? Rate of flow of charge. Therefore, delta Q came out to be R delta t. I is delta phi by R delta t into delta t. Cancel out, so my answer came out to be delta phi by R. Charge flow. Charge flow came out to be delta phi by R. Then, do you know what is the meaning of it? Do you know what is the meaning of it? Meaning simply indicates that if your flux is fast or your flux is slow, it doesn't affect the flow of charge. Yeah, it do affect the current, no? But not, it do affect the EMF, but not the charge flow. Why? Because no time, no time involved. No time involved. If no time involved, so delta Q is independent of the time one. Okay, so we can do one thing now. Let us give, I will give one numerical now that simply will join two chapters, EMI and current. One numerical. Let us just do one numerical. Numerical is, it will join your current electricity with your EMI. Numerical is, my resistance of coil is given as 10 ohm. Induced current gets induced current gets developed. This thing gets developed. Done. Why? By changing magnetic flux. How, sir? Look. Time second, current. It is given in this way, and is 0.1 second. Here is 4. It is given to me, right? Find flux. So what do we need to find? Flux. Sir, how to find flux? No? Do you know what is flux? Yes, sir. Delta phi. We know it now. So what we can get with this equation or with this graph? Do you know I equals to dq by dt? Yes, sir. What is dq? Is it I dt? Yes, sir. If I integrate it, so I will get my charge. Na? Charge is, this is area. Na? It is area under curve. What is area of this particular area? This thing. It is 1 by 2, base is 0.1. It is 4. It is 0.2. Yes. So charge came out to be 0.2 coulombs. Okay. So I guess Q equals to delta phi by R. Yes, sir. So delta phi came out to be Q into R. Yes, sir. Q is 0.2 and R is how much? 10. My answer is 2 Weber. Answer is 2 Weber now. So now you can see why the previous chapters are also important if we are doing a new one. Okay. I guess you got it now. Vinay Kumar. Hello, beta. Anshu. Hello, beta ji. 0.5. So I got your messages now. Na. This is very easy, no? So look, why these things is now? Because you have paid attention to the previous classes also, no? Look, I'm just getting too fast now. Do you know why? Because I know you that we had spent more than 2 months in this particular series. Now we completed electrostatics, capacitor, current, magnetism. Now we are doing EMI. That means we completed 4 major chapters from your 12th class. Okay, it is repeated, no? Let's do one numerical. This class will be very short due to some health reasons. So I will take this class for a very short time now. Don't worry about it. So we're having a numerical. I will write the whole language of the numerical. That is the radius of a circular coil having 50 terminals is 2 centimeter. Its plane is normal to the magnetic field. Let's suppose the magnitude. Let's have the magnetic field change. No? The magnetic field changes from 4 Tesla. Let us increase it. No, let us increase it. Just 2 Tesla to 4 Tesla. Let's increase it, not decrease. Okay. Time is given as 3.14 seconds. So find the E. Find E. How we can find the E? No? How we can find the E? Okay. Sir, I guess my answer is E equals to delta phi by delta T. No? Is it phi 2 minus phi 1 divided by T2 minus T1? Yes, sir. So what is phi 2? Is it NBA cos theta minus it is NBA cos theta? N is same, only B is changing, no? T is given as 3.14. Okay. So can I take one thing common? I will take NA cos. Here what we have? We have cos 0 degree only, right? Plane, no? Normal to the magnetic. That means it is in this way. Area. B is here. Theta is 0 degree. So we are having B1 minus B2 divided by 3.14. Then what is N? N is 50. What is area? Is area given to us? Yes, it is pi r square pi. What is r? R is 2 centimeter. It is 2 10 to power minus 2 whole square. B2 is 4 minus 2 and it is 3.14. Cancel out because pi is also 3.14. Okay. So I will write as it as a 50 into 4 10 to power minus 4. 4 minus 2 is 2. That means 1 0 cancel out. Here we are having a plus 1. Look, 4 5 20, 20 plus 2 40. It is 40 10 to power minus 3. Is it 4 10 to power minus 2? 0.04 volt. Easy or super easy? Easy or super easy? Huh? Easy or super easy? Easy, no? I know now. Today I'm just in a fast rush, right? But you don't know the reason behind it. So I guess you need to manage in this session now, okay? That's why I'm just calling this session off in earlier. Okay, let us do our last numerical. Then I will just wrap the session. I'm not able to just continue it for 1.5 hours. Okay, I hope you understand now. So we are having a numerical. Numerical is a coil and a magnet moves with their constant speeds 5 meter per second and 3 meter per second respectively towards each other. Then induced EMF is 16 millivolt. If both are moves in same direction now, same direction, their induced EMF is, we need to find it out. Then sir, how to find this one now? Okay, but one concept that I want to teach you now, that is, look, first one, my coil is like this, my magnet is like this. Okay, first one, they are just going towards each other. So this one is 5, this one is 3. What is relative velocity? Is it 5 plus 3? Is it 8 meters per second? First case. Second case, they are going in same direction. 5, 3. In second case, V relative is 5 minus 3. That means 2 meters per second. Done. What is E? Sir, E is delta phi by delta T. What is this one? Is it rate of change of flux? Okay. So is this relative motion? Yes. So E is proportional to my relative motion. Relative motion. I can write E1 by E2, V relative first divided by V relative second. I can write this equation now. But I'm having some sort of work now. It is a hell related things, right? You can see the pace of my class also now. I'm just going very fast, right? So E1 is given as 16, E2 we don't know. It is 8 by 2. Look, 2 1 2 4 are 8. So I guess E2 came out to be 16 by 4. I guess it is 4 millivolt. Don't worry, Naveta, don't worry. I'm having all the calculation in mind. Before the second month, no, I will just count and your whole syllabus. But today I'm having some important work to be done now. Hello, beta. I'm having a very important work, right? And it can't be just ignored. Okay, I hope that you can understand now. So in this class, we done a couple of varieties of numericals. Okay, and I guess that and then hope that you will revise this concept. Tomorrow you are having off. Okay, I was having planning to start a session on Sundays also, but this Sunday I'm just very busy with some different work. So do one thing, just revise your topics, revise the previous one also. Okay, try to do a more and more numericals, and definitely in coming days I will be showing you more numericals, a separate series on numericals only. Okay, coming days we are having a complete sessions. So as you know that we had discussed it now. So one thing that I will write end here, this class end now. So Monday will be a lecture number 3rd. Monday lecture number 3rd, right? And after your 12th, I will start the NCERT series. In NCERT, we will do solved, unsolved numericals. Then we are having a top 100 to 500 numericals. This series. Then we are having PYQ series. Okay. So before your examination, we will just complete your whole syllabus thrice or 4 times. Okay. Don't worry about anything. Okay. And in parallel, I will start 11th also. 11th in the same manner. I hope that you understood the session very well. And if you are having any doubts, you are most welcome, right? I have also attached my Telegram link to the channel's description part. Okay. If you are having any confusion or if you are having any kind of suggestions or doubts, right? So you are most welcome. You can just bring me a comment there also. No, but I am an NITian, right? I am not from IIT. I am from NITian. Okay. So do these things. In next class, we will be in a very good zest now, good timings. So I guess I need to take now leave. Thank you, beta. Thank you very much. Thank you. Bye. Good night.